All right, so yep, you need right triangles before you can use the Pythagorean theorem, sine, cosine, and tangent. And that's why we had that all labeled with the right triangle trig at the top of the reference sheet. And you need a total of 3 sides and angles, and you need to know at least one side. So I did take off half a point if you forgot to say you need at least one side. Or another way to say that is that it cannot be all 3 angles. And that one was like boxed on the right triangle reference sheet that you got to use for the quiz. So that's part of the reason why I can be a little more rigorous on the grading there on that. On problem 12, this one was to just also get at the point that what you take a tangent of has to be an angle. So even though it's labeled as x, you got to think, oh, that's an angle. Whenever I want to figure out the angle, that's when I'll do the inverse of the trig function, because that's going to take that ratio and then tell me what the corresponding angle is. So if you think about this, sine and cosine can't take, the ratio of 2 sides can't be 2, right? It's limited to 1 to -1. But for tangent, you can have opposite to adjacent be 2. So it would be a triangle, right triangle that looks like this. And if you do the inverse tangent of 2, the calculator has it memorized. And I did remind you on units, even though it was on the front of the quiz, I did a second reminder here. So I did take off a full point there out of 2, because I wanted to make sure you realized what you had there, that 63.4 was an angle and it was degrees, or you could have put your answer in radians if you had your calculator in radian mode. And let's see, you guys did a nice job on some nice sketches and pictures to get at the idea here. There is an assumption that it was a 90-degree angle, so you can always ask. You guys never ask any questions. You guys ask a lot of questions in class when we're going over, but on quizzes and tests, I very rarely have any questions. But it's okay to say, you know, I'm assuming that's a 90-degree angle. Is that all right? Because yeah, without that, you only have 2 pieces of information, so you really have to have an assumption to get that third piece of information that, you know, it was plumb. It was made square to the ground on there. And since it's a right triangle, we can use right triangle trig. Some of you use law of sines to do this, but right triangle trig's probably a little easier. So you can go opposite and adjacent are what we're looking at, so we'll use tangent. And if you go through the algebra, ends up coming up to be 11 feet. And that would be the minimum distance, because what happens if you make the ramp not as steep? What happens to the distance from the house? Or if you make the angle smaller, the distance gets longer. And if you want to minimize your materials, you make that ramp steep and short, right? So that's the case we're looking at. And then to find the length of the ramp, some of you used right triangle trig and did sine opposite over hypotenuse. I went ahead and used Pythagorean theorem, which we can do because it's a right triangle. And most of you put your answers in rounded to the nearest tenth, 11.7 feet. But if you're building a ramp, you usually don't do tenths of a foot, right? So you take that remainder, that decimal remainder on the feet, and change it into inches. So this would be actually like 11 feet 8 inches, rounding to the nearest inch on that. So because we hadn't gone over that in class, I didn't require you to do feet and inches, but you've seen that. So on the final exam, you should be able to write your answer in feet and inches if it's an application. Any thoughts or questions there?
Well, it does say 10 foot up there.
Yeah. Yeah, so I said you could do it either way because we hadn't looked at it in class. But now that we've kind of reminded you how you would do that if on the final test, if it said put your answer in feet and inches, I might not say round to the nearest tenth of a foot on there. Anything else there?